Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course operating system. In this lecture, let us go with the second approach of performing this deadlock avoidance. In our last lecture, we already learned about the resource allocation graph approach, where this approach can be used if you have single instance of your resources. But if you have multiple instances of your resources and if you want to avoid your system to enter into the deadlock, then you need to use this Banker's algorithm. So I'll quickly tell you Banker's algorithm will be applicable if you have multiple instances of your resources. So I hope you all are clear how the single instance, that is your resource allocation graph, can be used. So today we will see how multiple instances this Banker's algorithm can be used. All right. Now, what is this Banker's algorithm? What it does is it requires one input. Like whenever a new process is there or whenever some set of processes are there, they must tell how many number of resources they may need to perform to finish their execution. So in the Banker's algorithm, a resource may be multiple instances, okay, and also each process must tell how many resources it need to finish their execution. So that is the requirement of this Banker's algorithm. Okay, and this Banker's algorithm will be done in two-step process. The first step is it will go through the safety algorithm, where this safety algorithm will help us in checking whether if the requested resources are allotted, if they are allotted, whether it will lead to deadlock or not. And it will, if it is not leading to deadlock, then we can allot those resources like that to decide whether we could able to allot, whether we should able to allot or not. So this algorithm helps us in deciding that. Next one is resource request algorithm. In this, what happens in this resource request algorithm, if the process has already told how many resources it want earlier only, okay, and later sometime, if after some time it has requested some additional resources, then it has to go through this resource request algorithm. After those resources are allotted, then it has to go through the safety algorithm and it has to check whether the system is in safe state or not. Safe state is nothing but if this is your system and it is having two cases, safe and unsafe. Now, if your system is in unsafe, it is nothing but it is in deadlock situation. So if you could able, if you have come to a conclusion after going through these algorithms that the system will be in the unsafe state, then it means it is in deadlock state. In that case, we are not going to allot the resources that they are requesting, and by that we are going to avoid the system going into the deadlock. But suppose if you are going in, if you are determined like from this algorithm, this is the after allocating the resources, it is going into the safe state only, then we can allocate those resources to the requested processes. I hope you all are clear, right? Now, how can we determine, how can we determine a system is in safe state or unsafe state? That we can determine by going through this algorithm, which is called a safety algorithm. In this video, we will understand in detail about what is the safety algorithm, and we will see one example how to determine the safety sequence, whether if you could able to define the sequence or not. If you could not able to define the sequence, then it is nothing but you are in the unsafe state, right? So keep heading all of you, safety algorithm. So today we are going to understand about this safety algorithm in this video. Keep heading, safety algorithm. I hope the introduction and all is clear to you all, and why we are using this algorithm is also clear to you all. And if you feel this video is little bit slow and all, I suggest you all go with the 1.5 playback speed so that it will meet your expectations and you can learn the concept also. Okay. Now coming to the safety algorithm. Now what is the use of the safety algorithm? I have already told you it is used to find out whether the system is in a safe state or not. If the system is in a safe state, then that resources can be allocated. If the system is in unsafe state, then the resources what the process is requesting will not be allocated. Now how to find out the system is in safe state or not safe state? For that we have a safety algorithm. So the safety algorithm is defined like this. The first step of the safety algorithm is this one. Before going to learn this algorithm, for that algorithm, your this algorithm requires some data structures. What are the data structures is it will represent the it requires n variable which tells how many processes are there, and it takes m variable which tells how many resources are there. That means if you are considering process 5 processes, then n value is 5. And if you are taking 3 resources, then m value will be 3. So n represents number of processes, m represents the resource type. Now coming to the other type of data structures, it requires data structures like available, max, um, and then it requires allocation and need. So these are also some data structures that are required in this algorithm, safety algorithm. The data structures are available, which is a vector type, which tells how many this variable will tell how many resources are available. Max tells how many resources are required by each process. Allocation tells how many resources have been allocated at a particular time to each process, and a need tells how many more resources are required by each process to finish its execution. To understand this even more better, let us take this example. Okay, see this example, all of you. Now if you see this example, here we have considered 5 processes, so n value is 5. Okay, and we have considered 3 resources. Let us consider the 3 resources are A, B, C. So the M value will be 3. And you see, initially, let us consider A, we have, let us consider A resources are 10 resources, and B resources are 5 resources, and C resources are 7 instances. Okay, let us consider like this. So let us consider initially A has 10 instances, B has 5 instances, and C has 7 instances. Okay, instances is nothing but that many number of copies. That means if you have 10 printers connected to your system, then it is nothing but 10 instances. Like that, if you see, we have M means 3 values, 3 resources, and each resource, how many instances, that will be told by your available. So you can see here available, initially available is 10, 5 and 7. But if you see at a particular time period T naught, let us consider at a particular time period T naught. At a particular time period T naught, let us consider the P naught has told like it requires A resources of 7, B resources of 5 and C resources of 3. Okay, at that particular time, see here, I told you allocation and max are matrix type. That why? Because for each process, how many number of resources are allocated and how many resources are maximum required are represented in a matrix form. That's why they are matrix. Okay, now coming back here, at a particular time T naught, it is told like P naught maximum it requires 7, but at a particular time it has been allocated to 0 A resources only. And if it requires 5, but at a particular T dot time, it has been allocated with B resource 1 resource only. And it requires C resources 3, but it has been allotted with none 0 resources of C at a particular time T naught. Okay. Similarly, for P1, it requires 3, but 2 only has been allocated for A resource. 2 and 2 for B and C, but 0 0 has been allocated for B and C resources, and for P2, P3, P4 also, it means the same. Now, after available max and allocation is done, then we can figure out how many available are left. Initially, it is 10, 5 and 7, but after allocating, how much is left? See, how many allocated for all the process? In total, 2 plus 3. You could able to see, I think, 2 plus 3 plus 2. It is total of 2 plus 3, 5 plus 2 is 7. Out of 10, 7 are allotted. So available is 3. So that means 7 minus 10 minus 7 is 3. Simple mathematics. Similarly, 1 plus 1 is 2. Okay, out of 5 instances of B, 2 are allocated to all the process. Then we are left with 3. So available is 3. Similarly for C, 1 and 2, which is 3 out of 7, 3 are allotted. Sorry, 2 plus 1 plus 2, which is 5. Out of 7, 5 are allotted. So you are left with available with 2 resources only. So available matrix is a vector, and max and allocation are your matrix. And how many more needed? You need to find out the need matrix also. Need means this has been allocated, but to complete its execution it has to find out how many need is required. Max, it requires this much, but it has at a time t naught it has been allocated this much only. So remaining how much is required, that has been told by the need vector. What is this need vector for a particular process? You see, um, for the same example, if you see, need is like this. How it will be? If you can apply this basic mathematics here, the need will be like, you can understand from here. If at a particular time t naught, if these many number of processes are allocated, okay, that means out of requested 7, 10 only allocated, then how many required? 7 minus 0. Out of requested 7, 0 only allocated, then how many required more? 7 minus 0 is 7. So need is that one. That is what the formula. Max minus allocation. Max minus allocation we are doing. Same here. 5 minus 1 is 4. 3 minus 3 is 3 minus 0 is 3. Simple mathematics can be applied here, and you can fill the rest of the table. I hope you all could able to do this one. Okay. I'll again repeat for one more process. You see here for process P1, out of requested 3, 2 only allocated. So need is 1. Here 2 and 2 are required, where 0 and 0 are allotted. So minus 2 minus 0 is 2 and 2 minus 0 is 2. 2. So this is the need matrix. So this is how these data structures are required to go with your safety algorithm, and how these data structure values are calculated. I hope you all are clear. So the only input that will be provided to you is the number of processes, the number of resource type, and the number of instances. Along with that, the max and the allocation matrices are also will be provided to you. You need to calculate what is available. This has to be calculated. What is available is to be calculated, and what is need is to be calculated. After having these data with you, you can go with the safety algorithm and find out if the request, if this is requested, and if the processes can be allocated with this maximum number of resources, whether the system will be in the safe state or not. Okay, for that the algorithm is defined like this. So let us see that algorithm. So the first step of the algorithm is, safety algorithm is, you need to have one more variable called work variable, and you need to take another variable called finish variable. This finish is an array, and this is one vector, and this work value is equal to your available value whatever you are taking. Okay, and the finish represents an array where its value is equal to the number of process. It just tells the finish. That means each process has completed its execution or not. Initially, the finish of P0 and P1 and P2 and P3 and P4, everything is false only. Why? Because none of them might have not completed the execution. But if we need to get a sequence, the order of execution where all the processes finish should be true, saying like all have completed their execution by following this sequence. And the second step is, from the second step onwards, we need to find out one process. First, we need to find out one process. Let us consider the process is Pi. It can be P0, P1, P2, P3, any process. We need to find out a process whose finish value is false. That means its execution has not been completed, and its need value. Suppose if you are considering P0, its need value should be less than the work. Work is nothing but your available value. If it is true, then you need to go with the third step. If it is not true, then go with the next process, that is P1. Got it? Okay. We will solve the example also. No need to worry about that. And what is the third step? Third step is, if you could able to find out these two steps satisfied, then go with the third step. The third step is like this. What is that? Work equal to work plus allocation. That means once it is done, if it is true, need is less than the available, that means that requested number of resources are available, then what we can do, that many resources can be assigned to that process and it can finish its execution. After finishing its execution, whatever resources are there, that has to be added back to the available resources, right? So whatever is allocated, that has to be added back to the available resources, and its process execution has to be turned to true. Once this process is turned to true, we can go with the next process, which is going back to the second step and taking another process and checking whether it has completed its execution or not, and its need is less than available or not. If it is less than available or not, allocate the resources, get the work done, and release the resources, add it to the available, and then go to the next step. So this is a continuous process until all the processes turns the execution turn. Now, finally, if we could able to find out an order where all the processes have completed its execution, and for all the processes the finish value has turned to true, then we will say the system is in the safe state. So this is the important part. If all the processes finish value has turned to true, then we will say the system is in safe state. Then we will tell the operating system, the safety algorithm will tell the operating system, yes, the safety algorithm has passed. So you, what are the resources they are requesting, you can allot to them. But if you could not able to satisfy this one, then in that case, we will tell to the operating system saying like the system is in the unsafe state. Don't allot the resources to the processes. Okay, so to understand this even more better, let us go through the example, one example, and we will see. Okay, so what I will do for our understanding, I'll remove this part and I will solve here itself. Okay. All right. Now, let us understand what is the algorithm and how it has been solved for the same example. Okay. This is the algorithm. Okay. We will follow all these steps. Let us take first process P0. Okay. So, let us take first process P0. So, sorry. First process P0. Now, what is the first step we need to do? Work equal to available we have to do. Let us take one variable called work, and is equal to available. What is available as of now at time instance? It is 332. Okay, so 332. And then you need to take finish one array. Okay, let us take one finish array. And what is the size of this finish? 5, because we have 5 processes. So 0, 1, 2, 3, 4. So this is for process 0, 1, 2, 3, 4. And this is the finish array. Initially, the finish is false. So I will represent that one as false. Initially, for all the process, it is false. Okay, coming back here, let us take first process P naught. And then for P naught, what we need to do, because we need, the second step says we need to find out one process P naught. So we have taken process P naught. Now P naught, finish of P, we have to check. Finish of 0 is what? It is false. So we got, it is false. It will work. Now finish is false. Done. Now go back to the next one. Need of 0. What is need of 0? 743. Need of 0 is 743. Got it? Is less than or equal to work. Is less than or equal to, what is work? Work is 332. Okay. 332. Is it true? 7 is not less than 3. There itself it has come false. So the condition has been false. So if that is not existing, go back to the next step. Okay. What is the next process? Let us consider the next process is P1. Okay. So P1 I have selected. And for P1, finish of 1 is false only from our array. So I will make it is false. And then what is need of P1? 1, 2, 2. So 1, 2, 2 is less than or equal to work. What is work? 3, 3, 2. Right. Did you see here 1 is less than 3? 2 is less than 3. 2 is equal to 2, which is true. Now, once it is true, what is it means? Whatever it requires, 1 to 2, allot to P1. You can allot it to P1 and finish its execution, and it can, after execution, it will release that resources. The releasing means what? You need to go with this step. What is that? Work equal to work plus allocation. What is work? Work plus allocation is nothing but, what is work as of now? 332. So 332 plus what we need to do? Allocation. What is allocation? Allocation of 1. Allocation of 1 is what? 200. 200 that has to be allocated to work. So how much it is totally? 2 plus 2, 3 plus 2 is 5. Now it has been changed to 5. And then 3 plus 0 is 3. It has been changed to 3. And 2 plus 0 it is 2. So now work has been updated. And then what we need to do? Finish of I has to be made to true. So this has to be made to right. So in our array also, let us make it to. Now, after that, what we need to do? It is telling go to step 2. So let us go to step 2. We need to find another process. Let us find out another process. That is call it as a P2. Okay. Let us take it as P2. So P2 process I have selected now. And P2 again the same old steps we are following. Finish of P2 is false. Yes, it is false. Come here. What is need of P2? Need of P2 is 600. 600 is less than or equal to work. What is work now? It has been updated. So you need to take the updated values only. So 532, is it less? 6 is less than 5. No, it is not less than. So it has become false. So if it is not existing, we need to go with the next process. What is the next process? Let us take the next process as P3. Okay, P3 let us take. P3 of finish is, yes, false only. Okay, now what we need to do? Oh, so sorry. Here I have done mistake. It is not for P naught. I think you can see from this one. It is for P1, right? I hope what is the mistake I have done, you have understood. It is not for P naught. Okay, don't get confused. So this is for, this has become true from this condition. Okay. Okay. Now coming back to our P3. What is P3? Finish of P3 is false only. Okay. Now coming back, need. What is the need of P3? 011. So 011 is less than or equal to 532. Yes, 0 less 11 is less than 532. It is true. In that case, what we need to do? Allocate the resources to P3 and get the work done. Once the work is done, what we need to do? To the work. What is work? 523 plus allocated. What is for P3 allocated? 211. 211 is to be added. Allocated allocation is 211 only. So finally it has to be again updated. So 5 plus 2 is what? 7. So this value has become now 7. And 3 plus 1 is, sorry, 3 plus 1 is 4. And this has been updated to 4. and then 2 plus 1 is 3. This has been updated to 3. Now again we need to change this 3 finish to true. So this has been made to true. Okay, now after that we need to go back to the step 2 and we need to go with the next process. Let us take next process as P4. Same old approach. It is false only. What is the need of P4? 431, which is less than or equal to 743. Right. In that case, what we need to do? 74. We need to take 743 and allocation of P4 is to be added. What is allocation of P4? 002. Right. And then it has to be added to 1. So 7 plus 0 is 7, 4, 5. So it has been now updated to 7. I will write here. Work has been updated to 7, 4, 3 plus 2 is 5. Right. Okay. Now this has been changed to true. Now, any other process is still pending? Yes, still pending. P0 is not done and P2 is not done. So we will take P0 now again. Okay. I'll go back down. So we will take P0 again. And what is the need of P0? Need of P0 is 743. Okay. So 743 is less than or equal to 745. Yes. It is less than or equal to 745. In that case, what we need to do? Work is 745 is to be added with allocation of P0. What is allocation of P0? 010. So 010 is to be taken and added. And it has to be updated. Work has to be updated. Right. Now, how it will come? 7 plus 0 is 7. 4 plus 1 is 5. 5 plus 0 is 5. Done. And then now this work has been done. It has to be updated to true. Now we have one more process left. What is that process? P2 is pending, right? So P2 will start. What is P2 need? 600, which is less than or equal to 755, which is true. In that case, that processes need to be allocated and it can finish its work. After its work is done, what it has to do? Work plus allocation of P2. You can see here 302 is to be added from our algorithm. It has to be updated. Work has to be updated. 7 plus 3 is what? 10. And 5 plus 0 is 5. And then 5 plus 2 is 7. And this has to be made true. Okay, now if no process is there. So finally, if you see if all the finish of all the process is true, then we will say the system is in the safe state. How it has come to a safe state? We need to find out a sequence. What the sequence we have found? First, you can see from this approach, we have first completed P1, right? So P1 has to be allotted the resources first, right? And then you see from this example, not P2, P3. So P3 has to be allotted and then P4. Okay, P4 has to be allotted and then P0 and then P2. Okay, so P0, P2. So if this sequence, if you are following, then the system is in the safe state. That means the system can allocate all the resources and it will not lead to deadlock state also. So once this has come, we have got the safe state and then we are telling to the operating system, follow this sequence. Then the system is in the safe state and the processes can complete its execution and also the system will not be in the deadlock state. I hope you all are clear with this simple example. It may not be the case for all the problems. Some problems may not find out some kind of this kind of sequence. Then we will tell to the operating system, we could not able to find out such sequence. So don't allocate the resources. Got it? With this, we come to an end of today's lecture. Let us all meet in the next lecture. Until then, thank you all of you.